Good day to you. You are welcome to Linear Stereo College class. And the topic that we have here is elementary differential equation. And under it, the first thing I will be considering is the definition of a differential equation. What is a differential equation? Then types of differential equation, order of a differential equation, then degree of a differential equation, and what is a primitive. And the first definition that we have there is differential equation. An equation is said to be a differential equation if it involves derivative. So going to this first definition, any equation that actually contains a derivative is called a differential equation. For example, if you have y equals to, let's say we have y equals to y prime plus 2xy. So this is a differential equation because it involves a derivative. Then also we can say dy dx is equals to 2x plus y. This is also a differential equation. Then also another differential equation is, let's say we have uxx plus uxy equals to 0. This is a differential equation. Then also we can have xy prime plus 2y then minus n plus 5 equals to 0. This is a differential equation. Then also we can have 2 d square y over dx square minus 3 dy over dx all squared plus 5 equals 0. That is also an example of a differential equation. Then also we can have partial z over partial x plus partial z over partial y equals to 2xy. That is also example of a differential equation because all these equations that we have already all involves at least one derivative. This y prime can also be written as the y dx, and this y prime too can also be written as the y dx, and then we have the y dx equals to 2x plus y. So this dy dx is a derivative, and here we have the square y over dx square, here we have the y dx, so at least a derivative. So this one is partial z over partial x and partial z over partial y equals to 2xy. That is also an example of a differential equation. And here where we have uxx plus uxy is also an example of a differential equation because it involves at least one derivative. And this uxx can also be written as partial square u over partial x square plus, and this uxy can also be written as partial square u over partial y partial x then equals 0. So this particular one can also be written as this. So they are the same thing. So now when you have something like this, uxx, so here it can also be written as partial square u over partial x square. Now let's go to the types of differential equation. Under these types of differential equation, we can classify this into 4 different categories. The first one I will have there is we have ordinary differential equation, then we have partial differential equation, then we have stochastic differential equation, then we also have delay differential equation. So we'll be considering the first two, that is ordinary differential equation and partial differential equation. So now let's go to the first one, ordinary differential equation, ODE. What's an ordinary differential equation? An equation is said to be an ordinary differential equation when it involves only one independent variable. So any equation that actually contains only one independent variable is referred to as ordinary differential equation. For example, let's say we have dy over dx plus 2y equals 0. This is an example of a differential equation. Here we have dy over dx plus 2y equals 0. So the independent variable here is x and the dependent variable is y. So y is depending on x. So this is an example of an ordinary differential equation. Then also under other ordinary differential equation, ODE. So if you are given any differential equation, then you can see this sign, this particular letter D. If you have letter D inside the equation, that means it is under ordinary differential equation if you want to classify the differential equation. Then also, we still have more examples from ordinary differential equation. Don't forget that any equation that involves only one independent variable is referred to as an ordinary differential equation. Another example is, let's say we have the square y over dx square plus 2 dy over dx minus xy equals 4. So this is an example of ordinary differential equation because here it involves only one independent variable. With this letter D that we have here, that is to tell us that this particular equation is from ordinary differential equation. Then here we have only one independent variable, which is x. X is here, is just 1, and we have another x here. So both of them, they are still the same thing. So x and x, they are the same regardless of the power that you have here. This power has nothing to do with it. So we only have one independent variable, which is what? X. So again, we can have, let's say we have 2y prime prime plus 3y prime minus xy equals 0. So this particular example 2 is from ordinary differential equation. This is an ordinary differential equation. 2y prime prime plus 3y prime minus xy equals 0. It's also an example of an ordinary differential equation because this y prime that you have here, we can also rewrite this equation as 2 the square y over the x square plus 3 the y over the x minus xy equals 0. So this is an example of an ordinary differential equation. So when you see y prime prime, so you can later transform it to the square y over the x square. Now y prime can also be written as dy dx. So when you see something of this nature, they are both the same thing. So and they are still under ordinary differential equation. So now we are going to the second type of differential equation, which is partial differential equation. Under partial differential equation, this is the symbol for the partial. So this is the partial sign. So partial differential equation, that's the symbol. So under partial differential equation, the first thing I will take a look is the definition. What is a partial differential equation? An equation is said to be a partial differential equation when it involves more than one independent variable. So any differential equation that involves more than one independent variable is called a partial differential equation. And there are two ways in which you can actually identify a partial differential equation. The first one is by the time you see this partial sign, or if you are able to see more than one independent variable. For example, so let's say we have example 1, we have partial square y over partial s square plus partial square, okay, let's say partial square f over partial s square plus partial square f over partial y square equals to 2xy. So now this example that we have here is under partial differential equation because this involves more than one independent variable. So now this x that we have here is one independent variable and this y is another independent variable. So here this equation actually involves more than one independent variable. And don't forget, any equation that actually involves more than one independent variable is said to be a partial differential equation. So here we have x and here we have y. So now comparing this equation, this particular example that we have here, with this particular one, they are different. The number one difference that we have there is the partial sign, and here this is the ordinary sign. We have the square y over the s square, and then we have partial square f over partial s square. So here we only have one independent variable over here, which is x. And going to this particular example, there are two independent variables. We have more than one independent variable, which is what? They are x and y. So now again, so when we have uxx plus uxy equals to 0, this is an example of a partial differential equation because it involves more than one independent variable. So because this uxx can also be written as, we can write this as partial square u over partial s square. So partial square u over partial s square plus partial square u over partial y partial x equals 0. So this equation can also be written as this. So here we have more than one independent variable, and the independent variables are x and y. And also under this partial derivative, another example is, let's say you are given u dot dot then plus, okay, let's say we have partial square z over partial s square plus partial square z over partial y square, then minus partial square z over partial x partial y equals to 2. So this is another example of a partial differential equation because here we have more than one independent variables. So we have more than one independent variable. Now the next one that we have here is order of a differential equation. So to obtain the order of a differential equation, we'll go to the differential equation, the highest degree. The order of a differential equation is the highest degree which occurs in the differential equation. Order of a differential equation. The order of a differential equation is the highest degree which occurs in the differential equation. So now, for example, so let's go to the first example that we have there. Here we have dy dx plus 2y equals to 0. So now, the order of this particular differential equation is what? 1. That is order 1. Because the highest derivative that we have here is just 1. We only have dy dx. So we obtain the order here. So the order is here. Here we have the order dy dx. So the order is 1. Now let's go to the degree. The degree of a differential equation is we obtain that one from the highest order of the derivative of the differential equation, the highest order. To obtain the degree of a differential equation, we'll go to the highest derivative. Wherever we obtain the order of the differential equation, the power, that's the degree. For example, there's the differential equation I have here, the order is order 1. So here we have order 1, and the degree is 1, order 1, degree 1. So order 1, degree 1, because the highest derivative that we have here is just this, and the order is 1, the degree is 1. Let's have the square y over dx square plus 2 dy over dx raised by 2 minus y equals 0. So now this is another differential equation, and this one is from ordinary differential equation. So the order here is, so that's order 2 degree 1. So this is order 2 degree 1. This is the order. The highest derivative that we have here is this particular one, which is the square y over dx square. So this one is actually higher than dy dx. You are not checking the power that is here. We are checking this one that we have here, the highest derivative. So after dy dx, the next one is the square y over dx square. So the square y over dx square is higher than dy dx. So wherever you obtain the order, that is the same place you obtain the degree. So the order here is 2 and the degree is 1 because the power of this one is 1. So order 2 degree 1. So if you obtain the order here, you cannot go to this particular place and obtain the degree. It's impossible. So here we have order 2 degree 1. So now let's say we have y prime plus 2y prime raised by 4 plus 2x y prime equals to 2. So this is another example of a differential equation, and the highest derivative that we have here is 3. So that's order 3, and the degree of this one, the power is just 1. That's order 3 degree 1. So order 3 degree 1. So we can't say because the power of this one is 4, then we'll go to this particular place. No, it's impossible. So the highest degree that we have here, the highest derivative that we have here is prime. That's the third derivative. So this one is actually higher than the second derivative. So this is the order 3 degree 1. So now the other one that we have here is y prime raised power of 3 plus y prime raised power of 4 minus 2xy equals to 0. So now this is another example of a differential equation, and the order here is order 2 degree 3. The highest derivative that we have here is this particular one, y prime. So and the order there is, that's order 2, the second derivative, then degree 3. So you can't go to this particular place to obtain the order and the degree. It's impossible. So you can't say because the power of this one is 4 and this one is 3, you now say this one is higher than this one. No, it's not done like that. So wherever you obtain the order, that is where you obtain the degree. So here we have y prime, then everything raised power of 3 plus y prime raised power of 4 minus 2xy equals 0. So the order here is order 2 degree 3, order 2 degree 3. So here we obtain the order here, then we obtain the degree here. So the highest derivative, that is where we obtain the order. So then the degree will be the power. So now another example is, let's go to this particular example that we have here. Partial square f over partial x square plus partial square f over partial y square plus 2xy equals to 0. So as for this particular one, so we can see that the order is, what is the order? That's order 2, degree 1. So here, order 2, degree 1. The order here is 2, and the order here is 2. Because here, the highest derivative that we have here is the second derivative. So this and this are the same thing. That means you can choose any one. You can obtain the order and the degree from any of the two because they are the same thing. So you can say the order here is 2, then the degree is what? The degree is 1. So that's order 2, then degree 1. So order 2, degree 1. So that is the answer to that particular one. Okay, kindly like this video and share.